We're here at the Natural History Museum, and what is geology?
The study of earth and its materials.
Its processes and products.
Physical nature and history.
And our two focuses will be physical geology and historical geology.
So why are physical geology and historical geology important?
Let's
find out.
Let's find out.
What did the professor say about minerals again?
Well, minerals are naturally occurring inorganic substance.
Also, like a different chemical composition and a crystallized structure. But would a rock count like a mineral?
Well, a rock is not a mineral. Rocks are naturally occurring solid aggregates of minerals, mineraloids, or organic materials that form the Earth's crust and vary in composition, texture, and formation processes.
So we're going to talk about three different types of minerals: sedimentary, igneous, and metamorphic. So metamorphic rocks are formed by an existing rocks that transform by heat, pressure, and chemical process.
Sedimentary rocks are made from minerals or from organic particles found within the Earth's surface. They can be made either by pre-made rocks or from pre-living organisms.
Igneous rocks are formed from the cooling of molten magma or lava, either below or on the surface of the earth. So there are four physical properties for mineral. First is hardness, which is they have different scales, which is how hard you scratch it. And then we go on with cleavage, the second one, which is how it breaks. And then luster, how shiny it is. And lastly, color, what is its color? But it's not a good way to define minerals because same type of minerals can have different colors, or different type of minerals can have the same color. So it's not the best way to define a mineral.
Gold is a chemical element that is a bright yellowish solid metal at room temperature. It has been highly valued by humans since ancient times, called the gold, the noblest of metals. Prospectors sometimes mistake small pyrite veins and crystals for gold. Pyrite is the common fool's gold. It is made of sulfide minerals. You can see the comparison of the flour with the gold. 1 troy ounce equals 1.1 common ounce. It is real gold. Right here you can see the Sutter's Mill, Dorado County. The earliest reported California gold discoveries were placer deposits in the San Francisco Canyon in 1835 and Placerita Canyon 1842. Here in Los Angeles County, the discovery of gold at Sutter's Mill in 1848 set off California's Great Gold Rush, which drew tens of thousands of people to the Mother Lode. And the Natural History Museum is most famous for the Mojave Nugget being the largest one. Deposits form when very hot waters beneath the Earth's surface deposit gold in fractures in rocks. The Oroncho mine is a lode deposit famous for quartz veins containing rich pockets of leaf gold. The mine was first worked in 1860s and since that time has yielded nearly 6 tons of gold.
it's important to learn about minerals because it's a part of everyday life, resources for technology, health, and energy, and it also plays a big part of the history of the Earth.
So fossils are just bones?
No, fossils are more than bones. They help us determine the different time periods on Earth.
Really? How?
Let's go find out.
Triassic. 251 to 200 million years ago. Thick deposits of rock visible in the southwestern United States record a warm, humid environment. Forests of cone-bearing trees, ferns, and other plants grew in vast river floodplains. Other fossils from this time include some of the earliest known dinosaurs, which lived along crocodile-like reptiles called Phytosaurus, and predatory amphibians that weighed up to half a ton.
Next is the Jurassic, which took place 245 million years ago. Layers of rocks in the western United States contain evidence of what life was like in the Jurassic. The climate was marked by distant rainy and dry seasons. Broad rivers flanked by swamps went through the landscape. This was the age of some of the largest known dinosaurs, such as the predatory Allosaurus and the armored Stegosaurus, which grazed in the swampy forest. These giants lived alongside ancient crocodiles, lizards, and other animals.
From 145 to 65 million years ago was Cretaceous era. Rocks exposed in Montana, Wyoming, and the Dakotas took shape along the coast of a huge inland sea. They show the area had a subtropical climate and landscape of floodplains and river deltas. Small flowering plants grew alongside conifers and ferns. Animals included crocodiles, turtles, and mammals, which thrived along with the last of the large dinosaurs. As you can see from all these fossils, they give us an idea about what happened in the past, which includes dinosaurs, ancient plant life, and organisms.
Layers of rocks in the Central Valley called the Merino Formation hold our best records of life in the sea that once covered most of California. All of the fossils you see in this case came from these rocks, located far inland in Fresno County. There, we find fossils of reptiles ranging from turtles to giant Mosasaurus and Plesiosaurus. We've even found the remains of duck-billed dinosaurs whose dead bodies floated in the ocean and were covered with ocean silt and sand.
Rocks from the seafloor and dry land are fossil-bearing rocks we find in California's Central Valley, formed on the floor of the ancient sea. Slowly over time, layer upon layer of silt, sand, and debris settled to the bottom and became compressed into a rock. Over millions of years, geological forces lifted the seafloor above the water.
Scientific treasures. California is known for its mineral treasures. That's why it's called the Golden State. The rich fossil record of California is a scientific treasure, and students and scientists from universities and museums have helped develop a complete picture of California's lost world.
What's in the name? A field team unearthed one of the giant marine reptiles behind you in 1940. Dr. Chester Scott, curator at the museum, supervised the expedition to the Central Valley's Merino Formation. The plesiosaur was named the Monosaurus Salki in honor of Dr. Scott.
So what is climate change? Climate change is a long-term change in the Earth's weather patterns and temperature.
How do we know about climate change? The slow and continuous accumulation of sediment organisms in the deep ocean basins provides a detailed record of changes in climate during the past 65 million years. The rate of temperature change today from human-induced global warming is much faster than at any point in the last 65 million years. As you can see, it's been very hot in the 60 million years ago section, but once you go down the graph, you can see that in the 10 million years is where we had basically the ice age and had a spike in the temperature.
The mystery of large dinosaur disappearance has been a baffled and intriguing since the 19th century. The mass extinction was likely caused by dramatic change in the Earth's atmosphere and climate. Some think these changes result from an asteroid smashing into the planet. Others argue that they were caused by huge volcanoes that spewed dust and chemical into the atmosphere.
Climate change posed challenges for mammals. During the Ice Age, North America was home to a great diversity of large mammals. Many of these species survived through periods of rapid climate change, which happened throughout the Ice Age, but most became extinct during the last episode of warming, which was also the time when humans arrived in North America.
The climate back then was much wetter than it is today. The evidence to back up the statement will be the discovery of the freshwater snails that are 27 million years old. These snails live in water, which indicates that when they were either found in an environment with no or little bit of water. So this indicates that a long time ago, wherever these fossils were found, there was either a stream or a river that they lived happily in.
Mammals migrated as climate changed. Climate change caused by the movement of continents takes place slowly over millions of years so that mammals can usually adapt in the Ice Age. There were rapid shifts in habitats over tens of thousands of years as the Earth cooled or warmed. Those mammals survived by migrating to stay in the type of habitats to which they were already adapted.
So today we talked about geology, which is two parts: physical geology, which includes minerals, and historical geology,
Which includes geologic time and fossils.
And climate change.
and it's important to learn about minerals and geologic time to learn from the past to predict the future. And it's also important to learn where our resources are from. So minerals are resources for technology and energy, and where we get our petrols from, like fossils, gives us petrols. Yes.
Thank you guys for listening. We're out of here.